Just wanted to do a short webcast looking at Monte Carlo analysis and also combining distributions so that we can do simulations. And first of all, for the Monte Carlo analysis, it's pretty straightforward. 5 steps. Start with the distribution. For instance, we're looking at Harry's auto tire, and we've got demand for one tire, two, three, four, and five. We've had 200 iterations. Of course, they're scribbled in here, but they're discussed in more detail in the chapter. But out of the 200 overall, we had 10 that were zero demand, 20 that were one demand, 40 that were two demand, 60 that were three demand, 40 that were four demand, and 30 that were five demand. And we've created a probability distribution for that. So 10 divided by 200 is equal to 5%, so on and so forth, the whole way through the distribution. So we create our probability distribution. Secondly, we build our cumulative probability distribution, and we do that by simply adding the probability. So our first probability is 5%. So 5% plus 10% is equal to 15%. 15% plus 20% is 35%. 35 plus 30% is 65%. So you can see how that works. Then lastly, create your interval for random numbers. So if you chose a number between 1 and 5 for your 5%, that would be your random number interval. For 6 through 15, representing our 15%, 16 through 35 for our 35 up to our 35%, 35 through 65, and on to the end of the cumulative probability distribution to develop your interval for random numbers. This is not only important for Monte Carlo analysis, but also for when we create multiple distributions, which we'll do in a second. We can actually load that distribution. As you can see, it's all loaded right here for our values. And there are numbers, and of course we had 200 iterations that we were working at. It creates our probability, our cumulative probability distribution right here, and it creates, as we had discussed in earlier chapters, our cumulative probability distribution. And then we actually ran 1,000 iterations of this. And what we came up with was a daily demand, that many iterations, it's always going to come close to your expected value. But it comes out to 2.89, 2.896, which we have right there. So that's generally the process of creating that Monte Carlo distribution. We've got a nice distribution bell curve that shows how that all works out. And we can use that to predict different things. The second problem in the chapter was Simpkin hardware store, where they had a reorder point. Then they reorder drills every when the inventory drops to 5 drills. And they collected data over 300 days, and they looked at a lot of different issues, but delivery tends to take between 1 and 3 days. We can create two different distributions and integrate them, and that's really the basis for doing a simulation. But that is to take drill demand as one distribution, and the other one is our reorder lead time is our second probability distribution. And by integrating these, we can work effectively to see how they play out, and we can simulate, in this situation, a rather simplistic example. But drill demand, 15 times it was 0, 30 times it was 1. all up to 300. We divide by 300 to get our probabilities. We develop our cumulative probability distribution as we did just a second ago, and then create our interval of random numbers. We do the same thing for our reorder point here. And again, this is all discussed in the chapter. But does it take 10 times? It took 1 day. 25 times it took 2 days. And 15 times it took 3 days. We divide by our total number, which was 50 in this case. We get our probabilities. We get our cumulative probability distribution. And right there, our random number. We can then take this information and develop it into a simulation, and this is really our first simulation. So, for instance, let me see if I can get all of these distributions on one page. Let me go with, reduce that down a little bit, just for a second anyway, and then I'll go down and get, okay, there's all of our distributions and the first day's drills. But first of all, we day one, of course, there's no receiving. And our beginning inventory, actually it's just in the rules for this simulation, is 10. So we pull a random number. We get that random number from the random number table that's included in the chapter. And our random number is a 6. So we go up to our drill demand. It's between 6 and 15. And so our drill demand is 1. We put in a 1. Our ending inventory is 10 minus 1 is 9. Lost sales, of course, there are none. Do we reorder? No, because remember our reorder point is 5. Then we go to day 2. 0 received because of lead time and that type of thing. Inventory beginning is 9. We just pull it from the ending inventory. So beginning inventory is 9. We pull a 63. So we go up to 63, which is a drill demand of 3. And we see the drill demand right there for 3. So 9 minus 3 is 6. Lost sales are 0. Do we reorder? No, because again, our reorder point is 5. And we just simply keep running the simulation like that. And for instance, for day 3, 0 received because of the situation where we didn't hit our reorder point, so we haven't had to address our reordering and lead time. But we have a beginning inventory of 6. We pull a 57 from our list of random numbers. In 57, again, we have our drill demand. 57 is between 36 and 75. So we get a 3. There's our 3. Now our ending inventory, 6 minus 3 is 3. So lost sales, none. But yes, we reorder. And so we pull a random number, and our random number is 2. We now go to our reorder lead time. 2 is between 1 and 20. So it takes 1 day for lead time. And then we just go down to day 4. And we include that, of course. We simply follow through, just jumping right over to lead time. It takes 1 day in order to get the parts, or I'm sorry, the drills. And so we're able to get that right here for our units received, our new order of 10 drills. Again, 10 drills is in the list of instructions, and when you do reorder, it's 10 drills. But that's generally the process that we use to do a 2 distribution simulation. Now going down, there's a cost analysis that can be done, and that's pretty straightforward. I won't spend a lot of time there. New Orleans has another example, and we could go through that, but the theory and process is the same. And so that's kind of an overview of the overall simulation. We can also use Crystal Ball. Unfortunately, our program doesn't include Crystal Ball, but it will actually set up for you the various distributions. In this situation, it's the number of rental units, and also it can be expenses. So we can set up these distributions in a very effective manner using Excel programs. That's the end of this quick overview. Just wanted to present the basics.